And you're going to start putting fatty acids on here. You're going to put one here, then you're going to pick up another one, put it on carbon number 2, and then the adipose is going to make a decision at that point. It's going to say, well, I want to triglycerides, so you're going to pull off that phosphate and put the third fatty acid there. So there's an absolute requirement by adipose tissue for glucose because you have to have alpha-glycerol phosphate. Bear in mind, to get that glucose into the adipose tissue, you require insulin because insulin is going to recruit GLUT4 from the cytosol to the cell surface, so insulin is going to be required for fat synthesis as well in the adipose tissue. Liver doesn't have this problem. Liver doesn't have a problem because liver can take glycerol, of which there's going to be plenty, and you'll see why when we start to use the fat metabolism. The liver can take glycerol, and with an ATP to an ADP and glycerol kinase, you can make alpha-glycerol phosphate. Now, about 4 years ago, in the American Journal of Physiology, you think of physiology and knows some biochemistry. In the American Journal of Physiology, wow, look at their wealth of geneticists, found DNA with glycerol kinase in the adipose cell. So they immediately published a paper saying that the adipose cell could make glycerol kinase. They found a hunk of DNA that codes for it. They didn't bother to find the protein, and they didn't bother to put a little radioactive phosphate in that adipose cell and see if it would incorporate it into glycerol phosphate. And it wasn't about 2 weeks later it came out, well, no, that's not quite right. Another group looked at that and did all that and said, no, you can't phosphorylate glycerol in the adipose. So that reaffirms that the adipose has this absolute requirement for glucose. And that requirement being that you need glycerol phosphate. So that's the issue that has a requirement. TCA cycle. In that TCA cycle, we went around to citrate, isocitrate, alpha-ketoglutarate, succinyl-CoA, succinate, fumarate, malate, back to OAA. And we did this by dumping in acetyl-CoA. Well, oftentimes there are TCA cycle intermediates that leave. Alpha-ketoglutarate may leave to be used to make glutamic acid, just for overage. Succinate leaves to make some other amino acids. Malate may be leaving and going out to the cytosol. Anything that you do that pulls carbons out of here is going to limit OAA, and I think we said sometime last quarter that OAA is already precipitously low in the TCA cycle. So there's some thought that glucose is required to backfill the TCA cycle.